Well, welcome everybody to the November meeting of the Mount Shasta Stargazers. I'm glad you're all able to come out, on kind of a wet evening this evening to join us. And I appreciate that. So hopefully we'll have a good program for you and you'll learn something along the way. So when you go home, you'll be thinking about things that we've talked today and kind of stimulated your imagination and kind of your thoughts and
Can you see? Because you can
have a little
I can.
better understanding of the
It's
universe.
ready. You could get. Sure. Yeah. I mean, I can read it, but I have to look.
I see this now, Tom.
I think you can move over here. Well, maybe I won't.
Okay.
See that it's very sure.
Okay, so tonight, these are what we're gonna talk about. We're gonna talk about some of the activities that we did this last month. We actually had two major activities of the year that happened to occur during the same month. So we're gonna review that and show you what we had done. I know a question came up earlier about the interstellar comet 3I Atlas. So I'm not planning on talking about that. But we'll just leave it at the end. We have an open discussion at the end, so feel free to talk about it at that point. So this is our main program is our club member Jim will be talking about the PiFinder, which is, if you're not familiar with the PiFinder, I think you're gonna really enjoy his presentation.
Jim? John?
Yeah.
People are asking that you speak up. They can't hear what you're saying.
Okay.
That's why they're talking.
Yeah, no, talk as loud as I can. I'm sorry we don't have a microphone, but hopefully this will be good enough. Okay, so the first activity. Activities are photographs that I had taken at the beginning of the month. Now, as you all know, we've got a loaner telescope, the C-Star S50, that's available to club members. That they can borrow and take it out. So I thought I'd take it out just to give you kind of a little demonstration.
What's the diameter?
It's 2 inches in diameter, 50 millimeter.
Oh, that's where the.
Yeah, that's what it is. But this is the comet. I literally, set it up on a tripod, powered it on, it connected to my phone because I already had the control app downloaded. It connected to my phone, and I was able to go into the house and control the telescope from inside the house. If you get this picture here. So this is 2025 A6 comet Lemon, which is just past perihelion this last month, and now it's headed away from the Earth and away from the sun. But it was showing a lot of activity. This is the ion tail that you see here. That's ionized gases coming from the nucleus, which is down here, and the bright area around the front of it is called the nucleus. And then this kind of a brownish color here, that's a dust tail. So you have little micrometer sized particles that are being blown away from it due to the.
Could you share your screen? Zoom people won't be able to see.
Oh, they're not seeing it.
If I can make just a note. John mentioned that this C-Star S50 is a loaner telescope that the club owns. The club owns a number of telescopes. You have to be a member in order to borrow them. You normally borrow them for a couple weeks at a time.
Wow.
And it only costs $20 a year to be a member. And we have all this wonderful stuff that you can borrow, once you're a member, and you don't have to be a member to come to these meetings. This is open to the public.
We are a member.
Yeah, they're just letting everyone know
Everybody else, right?
that it's great.
And those telescopes are available for loan are on the website. So you can check out there to look at it. As a matter of fact, the library had a telescope in their back room that they donated to the club tonight. So I haven't opened it up yet to see what it is, but that's another telescope that we have. That's available. So are you seeing it now, Jim?
Yeah.
Okay. So like I say, it's this comet's been very active with the ion tail. You might have seen some other photographs online that show the different, streamers and knots and things that are coming out of it. Sorry about that.
Moving the sun sideways. The sun. So, yes, so.
And this is what it looks like through a larger telescope. This was taken a few days ago, and 30th of October, and 10-minute exposure. The stars are trailed because I'm actually guiding on the comet itself, which is moving against background star. But you can see, the intricate details of the ion tail coming off of there. So as comets goes, this was a very, very good one for producing a lot of details on the ion tail.
Jim, that must be your telescope, right?
That's just like it.
Okay, and then, thanks to Barbara Paulson, she was able to arrange for a private tour of the Hat Creek Radio Observatory that we did on the 23rd of October. It was led by Dr. Alexander Pollock. So there we are arriving. Typically, they have it set up for self-guided tours. So this is one of the places you start at for the self-guided tours, reading by. But we had Dr. Alex, who's given us the tour. And here you can see the number of radio telescopes here. I believe they have 24, I think is the number that comes to mind. Except for right now, but I look at their long-term plan. I think eventually they wanted over 200 to be built. So they're, if they meet their goals, then there'll be a lot more in the future. Now, this is one of the radio telescopes that they actually opened up, and we're able to look inside and see the different components and what's on the inside. Now, this here is a cover that we're removing from the front of the optical dome that they have on front of the radio telescope. So I took that off so we can see what it looks like. And there we are looking inside. And there you can see it right here. This is where that cover came off of, the glass covering the receiver there. And a close up of it. And that's what it looks like from the front. So the radio signals actually come down here off the big reflector and reflect down to the smaller secondary that's on the inside.
And that antenna is cooled down, the receiver antenna is cooled down to what temperature?
I don't know, it's
15 degrees above absolute zero or
yeah,
something like that?
it's cold.
Very cold.
Why does it need to be so cold?
It reduces the amount of noise that you get. Because you get a lot of background noise from the electronics and the temperature. So,
Is that Dr. Pollock?
yeah. There ain't things more, and, a lot of information, it was a lot more, detailed than I thought it was going to be, so. Everybody who came along were in for a treat. We'll be home. And they're, on the, details on the top side of it. And this is another, radio telescope that they have on the side.
Yeah. It looks so different.
Gold.
Yeah, it's used for, one of the European, programs, I don't recall which one offhand. But you can, find information on the site. And then they took us inside so we can look at some of the individual components. These are the spare parts and things that they actually use to maintain the radio telescope. So he's given, telling us about that and actually passing around some of the miniaturized electronics that go into the radio telescope. Now, this is their, signal processing, room here. And it's got a lot of, computers, along the side of the wall here. So we explain, how those work. And this is, what one of them looks like, you can see, not for the faint of heart. You're trying to figure out what's going on with one of them. And this shows a recent upgrade. What you have on the left here was the original configuration. And then after they upgraded with new processors and new computers, get really cleaned up. You can see what a difference it looks like. Okay, and the radio telescope, the Drake equation is what they're trying to solve. Trying to determine what all the different input values are to go into the Drake equation, so we can estimate how many civilizations are possibly out there in the universe. And after our tour, we went by to Bernie Falls and had a little picnic there. And this is the panorama I put together that she just showed you. The plane, how many radio telescopes that they have out there. So I think it was, well worth the effort. I know Lily has been wanting to go there for a long time, but she couldn't make this trip on the day that we had it. So we're going to do it again soon, Lily, so we can get you out there. Okay, the second one we had is the trip to the North Medford High School Planetarium. Now, this is our second time there. We went there last year for the first time, and at that time, the director, Megan Lorente, she was brand new and just kind of learning, but she still put on a good program last year. But this year, it was just a really step above. She's got a year experience on the operation of the projector and putting together programs, and she just did an outstanding job. And there's our roof sitting around, the interior. Now, the North Medford High School Planetarium, it was built in the 1960s, funded by NASA during the Apollo era, to educate the public, but it's still in operation today. They just recently, in the last couple of years, did a major upgrade. They redid all the seating on the inside and installed a new projector. They had an old Spitz planetarium projector, and they've modernized it now with something state of the art. So that's kind of what it looks like in there. And the planetarium too, they've got a lot of these little displays all over the place, giving history of the space program and different telescopes and things. But really interesting place. So when we do this again next year, I highly encourage people to try to make it. And this is one of the displays here, they're showing how the sun moves, throughout the year, how the different azimuths, at the same time. Along the ecliptic. And there's Megan there, and this is the new projector here, it's, probably about half the size of the old Spitz Planetarium, and it just does a really good job of doing simulations. They can feed a whole lot of data into it, so they can give you a lot of detail from the.
You got pictures on your screen.
Yeah.
Is the source button accidentally touched?
Well, it shouldn't have been, because control's down here. Yeah, this has not happened before, so. So that's, the way the planetarium looks today. And afterwards, they've got an observatory that's on the outside of the planetarium. And Megan opened it up to us, for us, and showed us some of the telescopes that they have in there. So you got a couple of Schmidt-Cassegrain telescopes here. And over here, this is a brand new solar telescope that they set up. And the high school, she's actually the astronomy instructor at the high school. And they have a lot of, motivated students that are actually doing research, with the telescopes here. He was telling us about one of our students that's actually doing, work with a solar telescope and working on a project. And what I like about it is, they've been doing this for many years, getting students involved with different programs. And when they completed the program, they actually come to the club, which meets in the planetarium here, give reports on what they learn. So it's just really an outstanding program that they have going on
Are those scopes operational, John?
there. Yeah,
What do they have, a roll-off roof? or-
yeah,
Oh, yeah.
the roof here rolls off completely.
I see.
Yeah, you can see the rail here,
Cool.
the chain drive that pulls it off, so you have unobstructed views of the sky when they roll it off. Okay, so for our upcoming events, I went ahead and put down a couple of potential star parties. And I know it's been difficult for people to get out there in the summer when it's really nice. And now that we're in November, it's getting cooler. But I felt that we should at least make an effort to offer up the star party for people who want to go out there and observe the dark skies before it gets too cold and the snow hits the area. So it's basically the 14th of November will be our primary, with a backup a week later. If for weather contingencies or whatever else. But what I'll do, I'll put out reminders and maybe do a poll to see if anybody's actually interested in going out and observing on one of those nights.
The Phoenix Sky Sanctuary is across the street from the McLeod Falls. You know where McLeod Falls are?
We know where McLeod is.
Well, it's right, it's a couple miles past McLeod.
Yeah.
7 miles past, thank you. 7 miles past McLeod on the left.
And what had happened about 4 years ago,
No, this is out in the wilderness.
It's just a place where we could go.
Yeah,
It's a
huge.
Clear cut.
I see. from a fire, and then they clear cut it, and.
Right, they had a fire about 4 years
Go on
ago
a
called
Forest Service.
Bradley Fire,
Wow.
and they,
And the skies are absolutely incredible. The Milky Way is just clear as anything.
Oh my God.
You can see, yeah, it's beautiful observing there. Yeah.
yeah, and there is a meteor shower going on, during that time period, so. You know, it might go out there just for a couple hours just to see if you can see some meteors. Because you really need dark skies to see the fainter meteors. Yeah, no, well, no, what that, we record the meetings to put them on our website so people who can't attend the meeting can go back later and watch them. And we've been including our YouTube video segments as part of that recording. And, you know, Jim's got a couple of notifications about copyright infringement, you know, warning. So we decided what we'll do, we'll just, you know, not record the YouTube segments or the what's up portion. And then put down the details of the meeting.
Email addresses.
Yeah, the link to the video that we watched. So everybody should be having that one.
So we can watch that on YouTube? or-
Yeah.
What is it, under Mount Shasta Stargazers?
Yep. Yeah. So Jim, you ready?
Sure.
So I don't know if you want to introduce yourself or
Really nice.
give some background.
Careful the bear. Oh, yes, okay. So,
I actually can stuff that in a little bit.
Down button. Yeah. Yeah, we'll just call that down button.
Okay. Well, thank you all for coming this evening. Can you all hear me okay? I think I talk a little louder than John does. So, this means I have a bigger mouth. It was the worst of times and it became the best of times. So I hope you'll excuse my mangling one of the greatest opening lines in classical literature, but it kind of describes the situation that I had with my telescope. It's this one, the Orion 12-inch Dobsonian. It's a wonderful scope. Many of you old timers will probably recognize it because I used to bring this telescope to all of our star parties. I think I brought it for about 10 years. Orion, unfortunately the now defunct Orion, called this an telescope. And they call it a telescope because it has the capability that if you align the telescope to two stars in the sky, then there's a device that you can hold. You can input any other object that you want to see in the sky, and then it would tell you how to move the telescope to see it when you look in the eyepiece. The 12-inch gives a beautiful view of the sky. It's a pretty large aperture. So why is it the worst of times? I broke it. This part here, I was assembling this computer on my driveway, and I was trying to get this part to sit onto the base of the Dobsonian thing. It's heavy. The mirror is down here, and I was having trouble getting it in there. And the more I tried it, the weaker I got, and I dropped it onto an encoder wheel, which is right in this area here. Well, I uttered a few naughty words, but after a while, I was able to get it onto the cradle, but the telescope would not align. No matter what I did, I lost my ability to automatically and easily find objects in the sky. One of the techniques that I have never learned is how to star hop. This is a mechanism whereby you can look at a star chart and you can pick out a series of stars and you can hop from one star to the next star and find objects. Our previous president, Russ, is very good at this. He he has a 12-inch scope like this, and he would bring it to the star parties, and he would lay out a star chart on his table. He would find some stars that he would use to find the object. He would go hop, 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 and within about 30 seconds, the object that he was looking for would be in his eyepiece. So it's a wonderful technique to have. Unfortunately, I never developed that technique. But then I remember that our current president, John, he brings a telescope to our star parties also. And he has a device mounted on it, which does equivalent thing that the telescope does. You basically tell it what object you want to look at. It tells you how to move the telescope to get there. And voila, when you look in the eyepiece, that object is there. I didn't remember the name of the thing, so I did a little bit of an internet search. And after a few misses, I finally found what the device was. And it's this device. It's called the PiFinder. When I mounted this object, this device onto my telescope, it was magical. I could use the PiFinder to find, once again, any object in the sky. And it's transformed the way I use the telescope. As I'll explain a little later, it's actually made it much better than the telescope ever was. So, the first question you might have is, why is it called a PiFinder? I mean, after all, this thing's meant to find stars, galaxies, and planetary nebula and other objects in the sky. As you probably have surmised by now, this device also has a computer inside of it. And the computer that's inside of it is called the Raspberry Pi. Now, if you think of the Raspberry Pi and you think of this, that would be a delightful treat. But alas, that is not what's inside the PiFinder. Working. This is what's inside the PiFinder. It's called the Raspberry Pi computer. It's a computer that's made in the United Kingdom, and it was meant for computer labs, technical institutes, to teach students how to program computers and how programs would interact with the computer. They called it a Raspberry Pi, I think, because in the early days of personal computers, marketeers were trying to make computers sound a little bit more friendly and less threatening. So they would name some of the computers after fruits. The most famous one, of course, is Apple. But there were others. There was tangerine, apricot, and others. So I think that the people who were designing this product decided to choose something friendly like raspberry.
How large is it?
I'll get to that in a second. The Pi part was a little more obscure. As I say, it was meant for students originally to learn how to program. And they decided that the preferred language would be a computer program called Python, spelled Python. And in fact, the guy who designed the PiFinder, in fact, uses Python as the computer language to program it. But I think they probably decided not to use PY as the pi part, because people would probably look at PY and try to figure out how to pronounce it, whereas pi is a little bit more natural. Anyway, it's called the Raspberry Pi, and the designer of the PiFinder decided that he wasn't going to call it a Raspberry Finder, which sounded a little weird, but he decided to call it a PiFinder. And it was in keeping of some other hobbyists who developed other things. For example, there's somebody who built a Pi weather station. So this kind of got the idea of using the word pi to attach to whatever the device is. So this is the computer. It's a simple board. There's nothing attached to it. It has no display. It has no power supply. It has no mouse. It has no keyboard. It has nothing. It's just a bare bones computer. I won't bore you with a lot of the details. I've annotated a couple of things. You can see here's the computer. There's the memory. There's a Wi-Fi chip, there's an Ethernet chip, a couple of USB ports. There's a display port here. There's this thing which is called the GPIO, general purpose IO, input and output. The designer of the PiFinder made use of this part of it to attach a GPS unit, which goes into the unit. So it can get the time, the date, and the longitude and latitude of wherever the telescope is located. And Lily asked how big this is. It's approximately 3.3 inches wide and about 2.2 inches tall. If you're trying to figure out a size, it's slightly smaller than a credit card. So this is a very small, very compact, but very powerful computer. So this is the computer that's inside the PiFinder. So the question is, what does this computer do? Well, the whole purpose of the computer is one thing. It's meant to determine where in the sky your telescope is pointing. That's the whole major purpose of the computer. And it does this by using a technique called plate solving. To understand the basics of plate solving, we've got to kind of go back to the origins of photography. In the late 1700s, people discovered that there were certain chemicals that would change their chemical composition when they were exposed to light. And so somebody realized that you could use this phenomenon to make images. And we won't go through the whole rigmarole of designing photographic plates, but over a period of about 75 years, it was determined that the best way to make images was to put these chemicals, which were that changed their composition or their chemical characteristics to light, onto something that was rigid, because these chemicals were not rigid. You had to put it on something. And they determined that something they would put it on are glass plates. So by about 1875, this was the technology that was used. Glass plate, emulsion, and then you would expose the emulsion by way of some camera. It's very, very good technique, and it was quickly adopted by scientific people, in particular by astronomers, who found it very useful to be able to take a camera and put it on the end of the telescope and take an image of whatever it was that they were looking at, and they could take the image then and process it later on during the day by someone who may not even be an astronomer. So here's an example of one of the plates. They decided to call these things plates, glass plates, but they were referred to quickly as plates. And this is a plate that was taken of the Andromeda Nebula. We know today, of course, that it's the Andromeda Galaxy, but when this image was taken, they didn't know it was a galaxy. They thought it was a nebula. And you can see that somebody has gone in here and made a whole bunch of markings on here. I can open this up a bit so you can see. I don't know if you can see it all there, but there's a bunch of numbers that they put with arrows pointing to the stars. This plate gives a negative, so stars are showing up as dots, black dots. And so somebody's annotated this thing. And I'm sure that those of you who are looking at this image of the Andromeda Nebula, or today galaxy, are probably not particularly impressed by this image. We're pretty used to the beautiful images that come from the Hubble telescope, or even ground telescopes make rather spectacular images. But I think probably for the people who were looking at this at the time, this was probably as spectacular to them at the time as the Hubble images are to us today. So the image, so the astronomer would take this photographic plate, he put it in the camera, which is attached to the telescope, would take this image and then develop it, and then he would put it into a sleeve. There we go. into a sleeve which would contain the basic data of what was on that image. And so there's a couple of things here. I'm not sure what the number in class are, but the two important numbers are the RA and DEC. RA stands for right ascension and DEC stands for declination. And these two coordinates can identify specifically any point on the celestial sphere. So with those two coordinates, you can identify it. No matter where in the sky it is, you can identify it. So you can see that, notice that here, it's given as 0 hours, 32 minutes. RA could be measured in degrees, but historically, for some reason, they've measured in degrees, in hours, minutes and degrees. The declination, however, is in degrees, 40 degrees. You can see that the date that the image was taken was October 27th, 1897. And it was exposed for approximately 60 minutes. So, and let me go back one thing here. Well, those of you with keen eyes, you probably noticed this line going down the middle here. Somebody broke the glass plate. And so you can see on the sleeve, the fellow has annotated that, I don't know who this guy is. I can only see W, and I don't know what those two guys are. But he broke it on November 7th, 1927. Just about 30 years after that plate was taken. In any event, between, over the decades that these images were taken, these were all taken by the Harvard Observatory. They probably accumulated hundreds, maybe even thousands of these kind of images, which were all located in these sleeves and were stored in the basement of the Harvard Observatory. And students or professors or researchers could go down and they could reference these and do measurements on the plates if they wanted to. Now, what I'm about to say is just a bit of conjecture. I don't know exactly what happened, but we know something happened. And my guess is that there was an astronomer one evening who was at the telescope, and he observed something that excited him. And he thought, oh my goodness, I have to get this into a photograph. And so he loaded the photograph into the telescope. He exposed it for 60 minutes. He took it away. He developed it. He got it all. And he made one mistake. This information, the RA and DEC, is determined by looking at the telescope, which has on it something called setting circles. And these are very carefully calibrated long before anybody uses the telescope. But it describes perfectly where the telescope is pointing. Well, in his excitement, he forgot to write down those two numbers. And so now he has a plate with an image that he's excited about, but he doesn't know exactly where on the celestial sphere it's located. Well, this is not a good thing to happen if you're doing science. So I think he walked into the Harvard calculators, as they were called then. They were all women. And these are the ladies who actually looked at those plates and were doing the measurements. They're the ones who are making those marks on the thing. And I think you can see here, this lady is got a magnifying glass. She's looking at a plate. She's probably doing some measurements down here. And I think she's probably reading them off. And this lady is recording them in a notebook. And the same thing is going on in this area here. So these people became very familiar with star patterns because they were looking at these things and they were measuring them a lot. By the way, just out of interest, this lady here, I believe, is Henrietta Leavitt, the discovery of the what do we call it?
Variable.
Cepheid variable. Thank you. Which eventually allowed Hubble to determine that the Andromeda Nebula is actually an Andromeda galaxy because it was so far away. In any event, this guy, the astronomer with the image without the proper coordinates, walked in and said, "Hey, can you help me? You got all these reference plates. Can you match the pattern of stars that's on my plate to some of the plates that you've already got in your library?" And so they made the attempt, and sure enough, they were able to find some plate in the library with star pattern that matched the star pattern on the plate that he hadn't properly annotated. And this was the first case of plate solving. The plate came from the glass plates that were recorded over a period of 20 years, perhaps, and the solving was finding out what that what the coordinates are, the RA and DEC coordinates for that unit. I don't know how long it took them to do this. I'm guessing hours, because they would have to go down to into the library and pick out each one of these plates and make a comparison and look for the comparison of the stars. But whatever it did, whatever it is, it took a fairly long time. And so this method is not very practical for solving location of a general purpose telescope. So let's jump ahead about 110 years. The world has changed in that 110 years. We're talking now roughly the time between the year 2000 and 2010. Even home computers are very powerful. They can do very fast calculations. They're relatively small, compact, and fast, and relatively inexpensive. So we have an enormous amount of computer power, even in a home computer. The other technology that is advanced is rocketry. We've learned how we can put telescopes outside of the atmosphere of the Earth up into outer, not quite outer space, but into space. And these telescopes can do very precise measurements of star positions because they don't have to deal with the aberrations that occur from variations in the atmosphere. And so a group called the European Space Agency in 1989 launched a satellite, which was called Hipparcos. I'm not sure I'm pronouncing that correct, but that's the way I think it's pronounced, which stands for High Precision Parallax Collecting Satellite. And I think they were trying to get Hipparcos to be as close as they could to this name, Hipparchus. This man was an ancient astronomer in Greece. He lived between 190 and 120 BC, and he is believed to have made the first known star catalog. The whole purpose of Hipparchus was to make a star catalog, so they tried to get the two to match. Hipparchus is also the discoverer or originator, I'm not sure what the right term is, of trigonometry. So if you've had difficulty in your school years of learning trigonometry, he's the guy to blame. In any event, it worked for about 4 years, and it did measurements of about 2 million stars in the Milky Way galaxy. And when all the measurements were made, they put together a catalog called the Tycho II catalog. Tycho is named after another astronomer, this one called Tycho Brahe, who lived in the mid-1600s to the early 1700s. And it was his observations of the motion of the planets that allowed Kepler to develop his Kepler laws of planetary motion. So I guess they decided to honor Tycho Brahe with this catalog, and they developed this Tycho II catalog. Yes, there was a Tycho I catalog. The Tycho II catalog, I think, was a little more precise. In any event, what you end up with in this catalog is a whole list, 2 million stars long, of stars, and each one of them has associated with it these two coordinates, the RA and the DEC coordinate for the position on the celestial sphere. And so they divided this catalog up into some sections. It could be anything you wanted to, but for the purposes of plate solving, it was probably someplace between 5 and 20 degrees. So they would divide this star catalog up into images that were 10 to 20 degrees. Now, they never actually make an image. This is just a digital plate, if you will. And notice that there are no plates involved with this at all. The data that was collected by this Hipparcos satellite was actually detected by CCD detectors. So there are no plates involved in it, but for historical reasons, they decided that they would keep the name plate solving just because it was a historical ideal. So anyway, you can put together these digital plates, which would cover 5 to 20 degrees of the celestial sky. And so you've got these things stacked, which cover the entire celestial sphere. So for the PiFinder, all the PiFinder has to do is now take a picture of where the telescope is pointing in the sky. And the computer is now going to do what those Harvard calculators had done. It's going to look for patterns and try to match the star pattern that it's getting from the PiFinder and match it to the patterns that are on these digital plates. So one of the things the PiFinder has to have a camera. And you can see the camera here. This is the lens. I'm sure this is the detector back here. The computer in here is very powerful and very fast. So this camera takes photographs approximately 10 times a second. So it's very, very, I think it can actually go up to 20 times a second, but I believe the way it's delivered, it's 10 times a second. The plate solving, the thing that took hours for the Harvard calculators to do, can be accomplished with the computer that's inside this device in approximately 10 milliseconds. For those of you that aren't familiar with the term millisecond, there are 1,000 milliseconds in a second. So you can see that's a very rapid solution to be able to get the plate solving done. So what happens next? So the PiFinder takes an image with the camera. The camera is detected with the detector back here. The plate, if you will, it's not an actual plate now, it's a CCD, it's probably a CMOS detector now, but it's got some detector back there, and it's got the stars located on it, and it presents that information to the computer, which then can solve to find out where in the sky the telescope is pointing. So at the end of the process, the PiFinder knows those two numbers that it wanted to get. It knows the RA, the right ascension, and it knows the declination. So it knows exactly where in the sky the PiFinder and therefore your telescope is pointing. Also built into the PiFinder are a whole bunch of different catalogs. There's a catalog for Messier objects, NGC objects, IC objects, stars, anything that any amateur astronomer would not want to look at. I think there's over 20,000 objects in the catalog. So let's pick one. Let's pick a Messier object. For those of you that are familiar with the Messier object, these are very familiar things that amateur astronomers like to look at. So suppose you wanted to look for M57, I think is the ring nebula. In the catalog that's contained in the memory of this computer would be able to look up M57. You would have the name ring nebula associated with it. But most importantly, it would also have the right ascension and the declination for that object. So now the computer knows where the telescope is pointing because it's done the plate solve. So it has the coordinates for where the telescope is pointing. It knows where you want to go because you've told it you want to look at the ring nebula. So it has the new RA and DEC information. And it can process to tell you how you have to move the telescope to get to that point. So it does that, and it presents that information in a very simple format. It shows two numbers. The first number is the azimuth or the right ascension direction, and the second number is the altitude or depth direction. And it's converted those numbers into degrees. So what the PiFinder is saying is move the telescope 29.4 degrees in this direction, move it 18.2 degrees in the vertical direction. And if you move it in that direction, when you look into the eyepiece, you will see the ring nebula. And lo and behold, it works. It's amazing. Now, as you're moving the telescope, you'd like to have some feedback. So as you're moving the telescope, what you'd like to see is that as you're moving it closer and closer, these numbers, 29.4 and 18.2, will start to move towards zero. But there's a problem. There's always a problem. And then the problem this time is when you're moving the camera, which is attached to the telescope, the camera is taking pictures very rapidly, but the pictures aren't usable. The reason is you're moving the camera and there's no longer stars on the virtual plate. They're now streaks. And the plate solver cannot solve streaks. It has to have points. So in order to provide a continuous feedback on how this works, inside the PiFinder, there's also an inertial detector. And it does a measurement using inertial techniques of how the telescope is moving. So while the telescope is moving and you're watching these numbers moving towards zero, the actual information is not coming from plate solving, but from this inertial detector. And that ends up with being something odd that happens because you move the detector and you come to zero and they're both zero and you say, I'm there. And then you stop the motion of your telescope. And at that point, the plate solver can now come in. And the plate solver is a lot more accurate than the inertial detector was. So very often it's off a little bit. So those numbers that were maybe very close to zero before might jump up to 2 or 3. It won't be far off, but it'll be somewhat off. And so once you get close to it, what I do at least is I go in what I call the bump wait technique. It's off by a couple of degrees. You bump it a little bit, wait for it to plate solve. It'll give you a new number, and then you just keep nudging it each dimension until you come to zero or close to zero. You don't have to get actually to zero. Depends on the focal length of the eyepiece that you're using, how close you have to get. But usually, if you get it within this number down to 0.25 on either one of those, the object will be in the eyepiece. This is the way I used the PiFinder over, I don't know, 5, 6, 7 times after I'd gotten it. And I was just absolutely delighted because the telescope now is usable. I don't have to learn how to star hop. I don't even have to align the telescope. I don't have to find 2 stars in the sky to go to. This thing is able to find exactly where it is just by the plates that are inside its memory.
Jim, do you have to enter also the location on the surface of the Earth, your longitude and latitude? Is that also required?
It's required, but you don't have to enter it because there is a GPS device built into it.
Oh, okay.
So the GPS device will give the latitude, longitude, date, and time. So it's all built in and you don't have to worry about that aspect. So I was at the computer one day and I thought, I'm going to review the instruction manual again. It's all online. This actually does not come with a printed manual. So I was looking through it and I came across a section that I had skipped before. And it had to do with the PiFinder Wi-Fi chip on that Raspberry computer. It turns out that the PiFinder has a Wi-Fi signal associated with it. And you can bring up your handheld device. You can take your phone, or I use an iPad, and you can actually connect your handheld device to the PiFinder. And this combination makes this device absolutely remarkable. So I did this with my iPad. And on the iPad, I have a program called Sky Safari 7. This is a planetarium program that you can download to your device. It comes in several flavors, one of which is free. Unfortunately, the free one, you won't be able to do what I'm about to describe to you. You can actually have to buy the plus version of this. The plus version of this, it costs, I think I paid $8 for it, so it's very reasonably priced.
Jim?
Yep.
When it says plus on iPad is the iPads that we're familiar with today.
That's it, yep, just your standard iPad. You
Does
can do it-
this thing show you, or can you determine from this if you're looking at two different stars?
Sure.
What the distance is between the two? In
I
light
don't-
years or whatever measurement you're using?
I don't know, I've never tried to do that, but I suspect you could, yes. At any rate, with the Sky Safari Plus unit, it gives you something here, down here, I don't know if you can see it, it's called a scope. And when you click on the scope, it brings up a little button that appears on the iPad saying connect. And when you tap the connect button on the iPad, it connects the Sky Safari Plus program to the iPad. And the two can communicate back and forth by the way of the Wi-Fi. So what happens is the PiFinder can send along the coordinates of wherever the telescope is pointing to the Sky Safari Plus program, and it can show you on the screen where it's pointing. In this particular case, I have it pointed at the Ring Nebula. And I don't know if you can see it where you're sitting, but there's this little kind of bullseye unit right there. And that's the position of where the telescope is now pointing. So it shows you exactly where on this planetarium program, where the PiFinder is located. So you could, if you wanted to, you could start moving the telescope and you could start moving it to this object and you could move it until you got it exactly here. You could try to do it that way. But it turns out there's a much simpler way. Suppose you wanted to go to this object. Is that M56, thank you. What you would do is you would take the iPad, you would tap the M thing on the iPad, and the Sky Safari would then select it. It would kind of put a little circle around it. You then tap on the go-to button here, and what happens is Sky Safari sends the right ascension and declination data, those two coordinates on the celestial sphere, to the iPad. The iPad says, oh, this is where you want to go. I can calculate what you have to do to move your telescope to get to that point. And so at that point, it will give you back this kind of display to show you how the telescope has to move in order to get, obviously, the numbers would be different. The combination of the Sky Safari with the PiFinder is just absolutely spectacular. It's just a joy and a delight to use. I can't tell you how much how much fun it is to use this telescope. And so, the best of times, here's my telescope now. You can see the PiFinder mounted on the finder shoe of the telescope. I have the iPad mounted also on the strut. Excuse me. And the two together are just a remarkable way of using this. Now, you know, well, I spent probably 40 minutes talking about Raspberry Pis and plate finding and all sorts of technical issues. Do you know what? You don't need to know any of this stuff to use the PiFinder. You don't need to know any stars in the sky. You don't have to align it or anything. All you have to do is put it on your telescope and turn it on. And then the one thing you have to do is you have to tell it what you want to look at. But after that, you just follow the directions, move the telescope the way the PiFinder says, and when you're done, you'll look at whatever it is that you want to see. You don't need any alignment stars. You don't need any knowledge of what stars are in the sky. You don't need to know anything. All you need to know is what you want to look at. So it's really a remarkable device. It's more like a television than it is a sophisticated astronomy gadget. You know, you buy a television at the store, you bring it home, you put it on a table or on the wall. You connect the power into the plug. You connect any cables you want. You turn it on with the remote control. You decide you want to look at something, I don't know, HBO. You turn it on and HBO shows up on the screen. You don't need to know any of the inner workings of how the thing works. The same thing with the PiFinder. You just turn it on, you tell it what you want to look at. You have to do one extra thing, you have to actually move the telescope. But beyond that, and you look in the eyepiece, and there it is. It's an absolute delight. The Sky Safari has another characteristic that I really like. It has the ability to make observing lists. So in the afternoon, I can sit at the desk and with my iPad, and I can put together lists of things I like to look at. I like to look at double stars, for example. So I can go through and I can select a bunch of double stars, make the list, and save the list to the Sky Safari program. Another thing I like to look at is carbon stars. Carbon stars are beautiful colored red or orange, but they're very beautiful colors, very beautiful stars to look at. So you can put together 15 or 20 carbon stars in which you want to look at. And then in the evening, you take the iPad, you mount it on your scope, and you bring up the observing list. You tap on the object in the observing list. The observing list then tells the iPad what the coordinates are, and it then shows you how to move the telescope. It's very quick. You can go through an enormous number of objects in a very short period of time. So it's a really, really remarkable device.
Jim, have you used this with your LX200?
I have not, no.
I assume it would work as well with that.
If you can mount it, if you can mount the device to it.
Yeah.
The shoe doesn't quite fit the mount on the LX200,
Yeah.
unfortunately. So are there any drawbacks to this thing? Well, there are a couple. The main one probably is cost. This is not an inexpensive device. The PiFinder is going to cost someplace between $550 to maybe $650, depending on how you get it.
Just looking today at it, 540.
540, okay. The difference in price between 540 and I don't know, maybe $600, I'm not sure what the price is. It's a difference of whether or not you have a battery built into the PiFinder. I chose to get it without the battery, and that's why you see this cord coming down here. The cord connects to a little power pack that's sitting on the base of the telescope. If you decide to go that way, make sure you check out which connections you need. I think this is a USB 3 that goes to the PiFinder. That's a USB 2 that goes to the power pack. That's a detail that you can work out. So cost is one thing. The other drawback is a potential drawback. I don't know if it will ever come true, but the company that makes the PiFinder is very small. And there's no telling that they're going to be around in 5 years. You know, if he doesn't make much money off of this thing, then he might well decide to close up shop. And so if something goes wrong with the PiFinder after that period, after he's closed it, we're kind of out of luck. And I'm afraid it's a real danger because there's nothing in the PiFinder that's unique to it. There's nothing proprietary to it. Anybody can put together a PiFinder if they wanted to. The algorithm for plate solving is free to use off the internet. Anybody can buy a Raspberry Pi computer. Anybody can buy a lens and a detector. You can put these all things into a box, and if you're able to do it very inexpensively, you might be able to undercut them. As far as I know, no one has done that yet, but I'm afraid it's a danger for the guy, and I hope it doesn't happen because he deserves success with this device, but it is a danger.
I think that is probably very close, if not identical, to the way the C-Star 50 does its work and other of these other smart telescopes.
Yeah, you're right. I mean, I think the main danger comes from China, and China is where all of these telescopes are made. So they've already got the plate solving stuff knocked for these so-called smart telescopes. They've got motors in them. They can control it in quite different ways. There's one other small negative to it. the PiFinder Wi-Fi is rather weak. And so, if you move your device, in this case, my iPad, very far from the, PiFinder, it can lose connection.
What's far?
4 feet, 5 feet.
Wow.
So it's not very strong. What I did before, I mounted the iPad on the telescope. I would actually hold it in my hand, and I would type in whatever I wanted or click on whatever I wanted. I would get the information transferred to the PiFinder. Then I take the iPad, I would put it on the chair next to me, a couple feet away. Then I would move the telescope to where it is. I'd walk over to the eyepiece, look at what I would look at for several minutes, however I wanted to look at. And then I wanted to go back and find the next object. So I'd go back to the chair, pick up the iPad, and bring it back, and it's disconnected. Now, 90% of the time, all I had to do is hit connect, and it reconnected, and it's as if nothing had happened, and it worked perfectly. 10% of the time, it didn't. I don't know why, but what happened was the iPad froze. There was absolutely no way for me to get it except to reboot the iPad. When you rebooted it, it worked fine again, but there was that one slight glitch. So that's why I decided to mount the iPad directly onto the telescope, where it would always be in the close vicinity of the Wi-Fi. So I don't know if this would solve any problems that you might have with your telescopes, but I can tell you that this is a remarkable device, and I've really enjoyed looking through the telescope with the aid that the PiFinder and the Sky Safari techniques provides.
Do you only need the Wi-Fi when you're using the Sky Safari? Like, could you just use the PiFinder with those arrows?
Yes,
And everything is contained right there. In other words, you don't
Everything's
even need
contained.
Wi-Fi.
the first 5 or 6 times I used the PiFinder, that's the way I used it.
So all the data is in there.
Everything is in there. That's correct.
It's a lot of data.
Yeah, the only problem is that the user interface is a little bit clunky. I don't know, maybe clunky is the wrong word. There's no keyboard on the PiFinder. So suppose you don't know what the Messier number is for, let's say, pick something, Sombrero Galaxy. You can use the PiFinder. It has a find function in which you can type in whatever object you're looking for. But it's a little clunky because there's no keyboard, and you have to use these little push buttons to do it. I've done it. It's very quick to do it. You do it once or twice, and it's very easy to do it. But it's a lot easier to use a keyboard. So, but the first 5 or times I used the PiFinder, I used it without the Sky Safari, and I was absolutely delighted. It works wonderfully.
I have a second.
Sure.
So how does the PiFinder know what your latitude and longitude is?
I'm sorry.
How does the PiFinder know what your telescope's latitude and longitude are?
Because it has a GPS unit built into it. So the GPS unit looks at the satellites that are up in the thing, right? And that's what you use in many of the driving instructions when you're driving a car. The GPS unit gives several things. It gives the date, gives the time, gives the latitude and the longitude. And so it knows exactly where the telescope is located. Yes, sir.
Do you have any idea on whether it can control go-to scopes through Sky Safari so that once you enter it, the scope will automatically move to it? If it's aligned, of course.
I don't know.
Okay.
I don't think there's any way to actually connect the two at the moment.
Well, Sky Safari will connect to the scope. PiFinder will connect to Sky Safari.
In which case you would probably not use the PiFinder Wi-Fi. You can actually use the PiFinder to connect the PiFinder to another Wi-Fi system. And I think what you would have to have is you would have to have the PiFinder, the telescope with the go-to on it, and your handheld device, all on the same Wi-Fi network in order for that to work. But I think it might, I don't, but I've never tried it. So,
Well, I think the answer, well, let me mention a couple of things that answer your question that you had here, in particular about the company going out of business and things like that, but Rich, I met him a couple of years ago at GSSP, that's when I discovered the PiFinder. But he's not interested in making money off of this thing. Everything he's done is open source. So you can go to the website, if you want to build one of these things yourself and you have a 3D printer at home, you can get everything that you need to build it yourself for about half the price. But the prices that you're quoting are for the assembled units. But again, open source, everything's freely available. He doesn't copyright anything. He's putting it out there to share with the world saying, hey, if I come up with this, see what you guys can do with it. And there's a group online that are taking it to the next levels, including controlling telescopes and things like that. So it's a continuous process, which is really kind of independent of Rich. He's there to guide them, but it's a whole community out there of individuals who are interested in this device that are improving it and making it next generation that'll even be better.
I want to caution you though, if you do buy the parts, you better have some experience, electronic experience of soldering to circuit boards. Because the circuit board connections are relatively delicate. And if you get the soldering iron too hot or you leave it there too long, you can easily destroy the circuit board. So I agree, it's a wonderful project, but you should have some experience with putting components onto a circuit board and knowing how to solder it there. Because it would be very easy to destroy that circuit board just by not knowing how to solder.
Yeah. And I think the same thing with the Raspberry Pi computer that's built in there. That was originally developed for hobbyists, people who like to tinker at home. And that original computers, I think they sold for less than $20 a piece. So hobbyists would order them by the dozens, just to build things. Just if you go online and just look up, Raspberry Pi projects, you'd be amazed at the geniuses out there and what they're doing with this thing. And so this, the PiFinder is just one application out of literally, I think, tens of thousands that you can find out there that people are doing with the PiFinder.
As of March of this year, the company that sells the Raspberry Pi computer, they've sold over 68 million of those computers. It's amazing.
Yeah.
And I believe they're about split halfway between schools and home hobbyists and then industrial applications. So these guys have really tapped into a market that I don't think anybody really understood how big it was.
No, if you've got imagination, I mean, it's the universe is yours, literally.
Chris?
We've got the same scope, and I know when I go on the site, you can order different mounting angles. And which is the one that is best for that scope?
All right. When I ordered it, I thought I was ordering what I wanted, which was that the PiFinder would actually be located, twisted around in the other direction where the eyepiece is.
Yeah.
So I ordered the right, or what's called the right-oriented PiFinder. It turns out if I wanted the PiFinder to be oriented toward the eyepiece, I should have ordered the left one. However, it turns out I actually preferred this the way it's worked out, because the light from the PiFinder and the light from the iPad are mildly bright. They're not overwhelmingly bright, but it's nice to be able to walk to the other side of the scope where the eyepiece is. Now you're looking at the back of the devices and you're not looking at the bright light. So I actually prefer it this way. So, but if you want the PiFinder to be on the same side, then for this scope, you'd want it a left oriented.
And it mounts on the same spot where I have the
Where you put your red dot finder.
right.
It's right on there.
It's, oh, great. You don't have to buy any special adapter.
No adapters required.
Wow.
Any other questions?
Thank you.
Well, thank you, Jim. Well, normally we would, open it up to, open discussions, but we are running a little bit late this evening, so. I guess we could have a few minutes if anybody has any quick comments that they want to make and.
Is all of this being recorded so that?
Yes.
We go home, we can get on the computer and get this and listen to the whole thing?
Yes,
and
but it's,
See the pictures?
it'll take a couple of days.
Are we just gonna get the audio part?
No, we'll get everything that you're seeing here.
It'll take a few days to get it up there.
Yeah, but it will be there.
I'm not very good at editing, digital file. I'm total rank amateur.
No. Okay, anybody else? Anybody?
It's a good meeting.
Oh, well, glad. Did we reach our goal? Do you guys learn something here tonight? They're going away.
Always.
Okay, good.
I'm gonna go get my 3D printer and my soldering iron.
There you go. Well, no, when I met Rich, he was at a table that had all these 3D printed parts, and I thought it was a Lego project that he was working on. And when he explained it to me, and I saw he had one already assembled,
Yes.
I talked him into selling me the one that was already assembled. So, that was a good deal on my part. So,
And does anybody else?
okay, well, thank you, everybody, for joining us tonight.
Have one of these?
Yes, John.
Thank you.
Yeah,
So I'm putting it in order tomorrow. I was waiting for this meeting. I'm gonna get what's called a flat.
Same star.
that'd be a good choice.
Yeah, they should, that's the best one for you.
Yeah, and although Jim, you mentioned it's an investment, but you can put it on any telescope.
Yeah.
You can put it on a pair of binoculars, you can put it on
Anything you want.
anything you want, so.
The glasses, yeah.